In this video, I went through my back catalog and found the best videos on graphing an ellipse. We start with graphing an ellipse from standard form and then working our way to graphing an ellipse in general form where we have to complete the square. We're going to graph an ellipse with a horizontal as well as a vertical transverse axis, and as well as label all the parts like the center, the foci, the major, as well as the co-vertices. Going through all these videos is going to give you a better understanding of how to graph an ellipse. I hope you enjoy. Welcome. So what I'd like to do is show you how to graph this ellipse, as well as be able to identify the center, the vertices. We'll even and do the foci. All right. So to be able to do that, when I'm looking at this equation, what I have is x squared divided by 16 plus y squared divided by 4. And what I notice when we're dealing with ellipses, the best thing I always like to look at is look at what is the largest denominator that I have. That is always going to be my a. So you can say that a squared is equal to 16 and b squared is equal to 4. Now that's going to be very, very important. The last thing we need to figure out is what is c squared. So automatically, first thing I want to do is identify what is my a squared, what is my b squared. And you got to make sure that your equation is equal to 1, which in this case it is. Then a squared for ellipses is always going to be the larger denominator, which in this case was 16. Now to find c squared, we have a formula that we have to apply. C squared is equal to a squared minus b squared. All right, so now I go and plug that. So I have c squared equals 16 minus 4. C squared is going to equal 12. So now I can just write that in there. So now that I've figured out a, b, and c, now it's time for me to understand where my vertex is. Now remember, your vertex is going to be, I'm sorry, not the vertex, the center of your ellipse is always going to be the center. Now, what we notice here is the center is in the form of h comma k. And usually what we'll have, instead of like having x squared, we'll have like x minus h squared. Well, as you notice, there is no h. It's just x squared. So therefore, h is 0 and k is 0. So in this case, I can also now say that my center is equal to 0, comma 0. So now let's go and plot the ellipse based on the information that we have. All right. So first of all, my center is at 0, 0. So I'm going to plot at point 0, 0 and write center. The next thing is now we need to identify my vertices and my foci. Now, from the center, the vertices are going to be a distance of a available. So we actually need to find the value of a. Now, more importantly, from the center, is my vertices going to be going left or right or up or down? And that's very, very important for us to understand. Because so what we need to be able to do is determine where is our major axis. And since my a is under the x squared, I can now say that my major axis is horizontal. So to determine your major axis, it's always going to be which variable your a is under. So if my a was under the x, my major axis is horizontal. If the larger number 16 was under the y, then my major axis would be vertical. So since it's under the x, I have a horizontal major axis. So what that's going to tell me is my vertices, my foci, and my vertex are all going to lie on the major axis. Therefore, which is horizontal. So therefore, since the center is already on the x-axis, I know that my foci and my vertices are also going to be on my x-axis. So if a squared equals 4, I can now say that a is then equal to 4. So therefore, from the center, I'm going to go 4 units to the right and 4 units to the left, where the absolute distance would be 4. So therefore, I go 1, 2, 3, 4, and then left 1, 2, 3, 4. So those are my vertices. Now, I didn't state what the co-vertices are, but the co-vertices would be a distance of b. So b equals 2. So that's going to be the opposite direction, which would b would make my minor axis, which is vertical, which is my minor axis, which is vertical. And I didn't say to go and find them, but that's one thing. Those are what we call our co-vertices. And then remember, the foci is between the center and the vertices, and that's a distance of that's going to be a distance of c. So in this case, I'm going to say c is equal to the square root of 12, which is equal to 2 square root of 3. And square root of 12. 2 square root of 3, so that's going to be between 3 and 4, roughly, right? Because 3 squared is 9, and 4 squared is 16. So it's going to be somewhere between 3 and 4. Obviously, I don't have the most accurate graph in the world, so I'm just going to estimate between 3 and 4. 1, 2, 3, or 1, 2, 3, and 4. So I'm just going to put it right there, and then to the left. And these are going to be what we call our foci. Now I can go ahead and graph this. OK. And there you go, ladies and gentlemen. That is how you graph your ellipse, as well as to label the center, your vertices, co-vertices, and foci. Thanks. Welcome. All right, so what I have here is x squared minus 2 divided by 9 plus y minus 1 squared divided by 4 equals 1. And what we want to do is be able to graph this ellipse, as well as identify the center, the vertices, co-vertices, and foci. So the first thing I want to do is identify my a squared, my b squared, and my c squared. And I'm going to do that by first looking at this and identifying the larger denominator, which is always going to be my a squared, which in this case you can see is 9. So I'll say a squared equals 9. Therefore, b squared is going to be the smaller, which is 4. And c squared is equal to a squared minus b squared. So c squared is equal to 9 minus 4, which is equal to 5. OK, so now I found out my a, b, and c. And that's going to be very helpful for me to identify how to find the vertices, co-vertices, as well as the foci. The next thing I need to do is identify the center and also identify where is my major axis. Is it going to be horizontal or vertical? Now remember, in the standard form of the equation, you can see that my center is always going to be at hk. So in this case, where its center is hk, where in this case it's going to be x minus h squared over a squared, which in this case is 9, plus y minus 1 squared over b squared, which in this case is 4, equals 1. That's k. So therefore, since you can see we have a -2 and a -1, remember, it's x opposite of h. So opposite of -2 is going to be 2. Opposite of -1 is going to be positive 1. So therefore, I can say my center is 2, 1. And the next thing is, now I look at, all right, so my a squared I said was under the x. Whenever my a is under the x, I know that my major axis is going to be horizontal. So I'm going to have a horizontal major axis. OK, so now to be able to graph as well as determine the information, I think it's most important to plot what I currently have. So I have a center at 2, 1. So I'm going to go over 2, up 1. All right? So that is going to be my center, and I'll label it appropriately. Now, again, I'm going to have a major axis. So it's not really a part of your graph, but a lot of times I like to write in that dotted line, because what's so important about this is, remember, the major axis holds the center, which we already see is on there, the foci, and the vertices. And why that's so important is the distance from the center to the vertices is a. All right? Now, we notice if I want to find that distance, I'm going to be going left and right. The distance from the center to your foci is c. And again, I have to go along this major axis. So my vertices and my foci are all going to lie in this dotted red line, where my co-vertices is going to be perpendicular to that line. So again, let's figure out what a is. So if a squared is 9, we can say a equals 3 as I take the square root of both sides. So if my center is at 2, 3, I just need to go 3 units to the right to find one vertice, and 3 units to the left to find the other vertice. So I'll go 1, 2, 3. That's vertice 1. And then to the left, 1, 2, 3. That's vertice 2. So let's go ahead and write these down. So I have my vertices are now at 5, 1, and -1, 1. All right. And one thing that's very important is notice that the center, the vertices, as well as the foci are all going to have the same y coordinates because they all lie on that major axis. The next thing we need to do is identify my co-vertices. So the co-vertices is going to be a distance of b from there. But remember, if this is the major axis, then my minor axis is going to be perpendicular. So now I'm going to be going up and down for my co-vertices. So if b squared equals 4, I can say b equals 2. So take the square root of both sides. So I'm just going to go up 2. So I can say covertice is at 2, 3, as well as 2, and just subtract -1. So that's covertice. That's my covertice. All right. Now, lastly, what I need to do is be able to identify what is my foci. So my foci is going to be distance of the square root of 5. So if I know c squared equals 5, take the square root of both sides. C equals the square root of 5. So again, I need to go square root of 5 to the right and square root of 5 to the left. Now, the square root of 5, I'm just going to approximate, is going to be anywhere between square root of 5 is anywhere going to be between 2 and 3. So I'm just going to go over 1, 2, 3. So just say here's one foci, 1, 2. There's the other foci. I'm just trying to approximate the best I can. And now, so when writing into my foci, again, I'm going from the center. So I know that the y coordinate is always going to be the same. I don't need to worry about that. I know it's going to be 1. All right? But now I just went 2 plus the square root of 5 and 2 minus the square root of 5. Right? That's all I put in. I took 2, and I added square root of 5, and then I subtracted square root of 5. So those are going to be my two foci. I have my vertices, my covertices, and my center. Now I just connect the vertices with the covertices, and I graph a very ugly ellipse, but that's going to be something where it's going to look at. So there you go, ladies and gentlemen. That is how you graph an ellipse as well as plot the information. Thanks. Welcome. So in this case, what I have is x squared divided by 25 plus y minus 2 squared divided by 36 equals 1. And what I want to do is show you how to graph the equation of the ellipse. But to be able to do that, we need to be able to identify the center, the A, and the B. So first we need to identify what type of ellipse are we looking at. Is the major axis vertical or horizontal? So to do that, we always know that the A in an ellipse is always the larger number. And you can see that the larger number squared is going to be 36 over 45. Therefore, I can say that this term is a squared, this term is b squared. But more importantly, the a squared is under the y minus k squared. So when I'm looking at my general form, the reason why I'm talking myself through this is I'm writing my way through the general form because there's two of them for an ellipse. And this is going to be the general form when I have a major axis that is vertical. So therefore, I know my ellipse is going to be a vertical ellipse. All right. But what's important about now that I know this formula, I can just say, OK, x minus what is x squared? Well, that's just going to be 0, right? So the center is h comma k. Well, since h is 0, now we need to figure out k. Remember, it's at y opposite of k. So y opposite of 2. So therefore, k is going to be equal to 2. Now I need to determine what my a squared is. Well, since we know that the a squared is under the y, I can say that a squared equals 36. So therefore, taking the square root of both sides, I have a equals 6. Then b squared is going to be equal to 25. And therefore, b equals 5. Okay? So these are very important because remember, not only the center is obviously the center of the axis, but the vertices and the foci all lie on that major axis. And since we know that a, the distance from my center to my vertices, is under the y, that major axis is going to be vertical. So let's go ahead and graph where the center is going to be, which will be at 0, 2. All right. Now, remember, a is the distance from the center to your vertices. So I'm starting at, here's my center. The distance is 6. Now, remember that the center, the vertices, and the foci all lie on the major axis. And the major axis is vertical, which in this case is my y-axis. So from the center, I'm going to go up 6, 1, 2, 3, 4, 5, 6, and find my first vertice. But remember, the center is in between the two vertices. So I can go down 6 units, 1, 2, 3, 4, 5, 6, to find my other vertice. Now, the next thing is I need to determine the covertices. Well, the covertices are on the minor axis, which is perpendicular to the major axis. So instead of going up and down, the covertices are on the minor axis, which is going to be, in this case, to the right and left. So I'm going to go over 5 to the right, 1, 2, 3, 4, 5. And to the left 5. 1, 2, 3, 4, 5. Okay? So now I've been able to determine the vertices, the co-vertices, and the center. Last thing I need to do is determine what c squared is, because c represents the distance from the center to the foci. So the formula that we have for c squared is c squared equals a squared minus b squared. Well, c squared equals 36 minus 25. C squared equals 11. Now I take the square root of both sides. Therefore, c equals the square root of 11, which is roughly going to be 3 and some change, right? 3 and a decimal point. So I'm going to go up 3, 1, 2, 3, and it's in between 3 and 4, and 1, 2, 3, in between 3 and 4. And I'm going to label those as my foci. Okay, so there you go, ladies and gentlemen. That's how you graph it. A lot of times they do want to at least identify what is the vertices, the foci, and the center. So we know the center is at 0, 2. Remember, the vertices are the exact same. The vertices have the exact same x-coordinate. They're just up and down 6 units from the center. So my vertices are going to be 0, 2 plus 6, which would be 8, and then 2 minus 6, which would be negative 4, which you can verify my 2 vertices. Now the 2 co-vertices have the exact same y-coordinate as the center, but now they're just shifted left and right. So my co-vertices are going to be to the left 5, which would be negative 5, 2, and to the right 5, 2. And then the last one, which would be the foci, those are going to be, again, on the same thing with, what did I do wrong? 0, that should be 0. The foci, remember, lies on the major axis with the vertices and the center. So therefore, it's going to be 0, comma. Now, all I'm doing is I'm adding the square root of 11 to 2, and I'm subtracting the square root of 11 to 2. So I can write that as 2 plus or minus the square root of 11. All right, and you can break that out into 0, 2 plus the square root of 11 and 0, 2 minus the square root of 11. But since the square root of 11 is an irrational number, we like to leave that in our answer. But there you go, ladies and gentlemen. That is how you graph the ellipse, as well as identify the vertices, co-vertices, and foci. Thanks. For this one, Ava, what they're asking us to do is they're asking us to find the coordinates of the center, the foci, the lengths of the major and minor axes for the ellipse with the given equation. Then we need to graph it. All right. So first of all, we need to understand where is our A and where is our B. Remember, when dealing with an ellipse, Ava, what we have is A is going to be your larger number, because remember, A is your distance of your major axis. So in an ellipse, A is always going to be larger than B. So we can determine that my A squared is under my Y, right? So automatically, I know since my major axis is under my Y, I'm going to have a vertical ellipse again, right? Again, another vertical ellipse. Yes, I read it? Squared? OK. So now, since I know that, that means I'm using this equation, x minus h squared over a squared equals x minus k. Why am I doing, y minus k squared over b squared equals 1. All right, so now, did I switch the, geez. I'm like just a mess here. OK, we're using this one, y minus k, x minus h. All right, so that's the form we're using, because now we know that since my A is under my Y, we're dealing with a vertical. And they're asking us to graph it. So let's go ahead and figure out what important parts do we need to know. The first one is determining the center. Remember, the center is h comma k. So in this case, when you look at your formula, h is 3, k is 1. Because remember, it's always the opposite. So let's go over 3. 1, 2, 3, up 1. So now I found my center. Now we need to determine our vertices. All right? So let's go and find the main vertices. So the vertices, remember, is going to be a distance of A, right, from the center. So if we know A squared equals 36, then we can say A equals 6. Now, since we determined, ladies and gentlemen, that this was a vertical ellipse, are my vertices going to be above and below the center, or to the left and to the right of the center? Above and below, right? So to find my vertices, it's going to look like this. Your h is going to remain the same, but your vertices are now going to come in this form of this. So your vertices takes a general form of h, comma, k, plus or minus a. So your h remains the same of your center, right? 3 is not going to change. But now what you're going to do is you're going to add your a to the k. And you got to add or subtract it. So let's go and take a look at this. So my h is 3, right? And my k, I'm sorry, my h is 3. My k is 1 plus or minus 6. So therefore, I'm going to have two vertices, which are 3, 7, and 3, negative 5. All right, and let's look at that. Let's plot those points. So over 3, up 7. 1, 2, 3, 4, 5, 6, 7. Down 5. 1, 2, 3, 4, 5. So what I've done is now just plotted my two vertices. All right. The other way you guys could do this is you know that from the center to the next vertex is 6 units, right? So you could just go to the center and add 6. 1, 2, 3, 4, 5, 6. And you get to your vertice. And then just subtract 6. 1, 2, 3, 4, 5, 6, right? So now what we've just created is our major axis. Yes? Now, there's one more thing that lies on that major axis. Anybody remember? The foci, right? We'll get to the foci here in just a second, though. Let's go and determine now what the covertices are. So the covertices are your distance of b. So we know b squared equals 1, so therefore b equals 1. Now notice the covertices, though, are now going to be, if your vertices are up and down, your covertices have to be left or right. So my covertices is going to be a little bit different equation. Now it's going to be h plus or minus b, comma, k. Because now the h coordinate on my center is that's where I'm going to be moving. So I'm going to be moving 1, shifting 1 to the right, and shifting 1 to the left. But if you just want to look at algebraically, it looks like this. 3 plus or minus 1, comma, 1. So that's going to give me coordinates of 4, comma 1, and 2, comma 1. So let's plot those. So those are going to be my two covertices, right? And you guys don't really need to do all this algebra work, Destin, because when you're looking at this, you can just say, oh, my value of b, I'm just going to move it from the center, 1 to the left and 1 to the right, correct? But then you guys can at least see algebraically how we do this. Now, we talked about our last distances, our foci, right? And the foci is going to be what really what's going to help us out. But remember, our foci is going to equal to c. And we need to figure out what c is. So remember, there was a relationship we talked about. A squared equals b squared plus c squared. That is the relationship of your distance a, b, and c of an ellipse. And remember, c is the distance from your center to your foci. So now I need to solve for c. So therefore, I know that a squared equals 36, which equals b squared, which is 1, plus c squared. So I subtract 1, and I get 35 equals c squared. Take the square root, take the square root. C equals the square root of 35. Now, I can't reduce that, but if I give that a value, that's going to be roughly like 5.89, something right around there, right? It's going to be high in the 8, 9 range, 5 point something. So what I'm going to do, though, is where is that vertice? Remember, my foci have to lie on my major axis. So anyways, just to kind of talk about the foci, to give you guys the general formula, since this is a vertical ellipse, I'm going to be adding or subtracting the foci to my h coordinate. So it's going to look something like this. To my k coordinate. H, comma, k plus or minus c. Now, we're going to come into a little bit of a problem here because we can't add the square root of 35 to my k coordinates. But anyways, it'll look like this. 3, comma, 1 plus or minus the square root of 35. Now, I can't evaluate this. We could go to decimal form. And when you do guys get to decimal form, you're going to see that it's going to be, your foci are going to be like right next to your vertices. All right, because as we talked about, the square root of 35 is 5.9 something. All right, so now just to go and graph it, connect to my vertices and my co-vertices, and there it is. So now what I've done is showed you the center, the foci, the vertices, and the co-vertices. Welcome. All right, so what I have here is x squared minus 2 divided by 9 plus y minus 1 squared divided by 4 equals 1. And what we want to do is be able to graph this ellipse as well as identify the center, the vertices, co-vertices, and foci. So the first thing I want to do is identify my a squared, my b squared, and my c squared. And I'm going to do that by first looking at this and identifying the larger denominator, which is always going to be my a squared, which in this case you can see is 9. So I'll say a squared equals 9. Therefore, b squared is going to be the smaller, which is 4. And c squared is equal to a squared minus b squared. So c squared is equal to 9 minus 4, which is equal to 5. OK, so now I found out my a, b, and c. And that's going to be very helpful for me to identify how to find the vertices, co-vertices, as well as the foci. The next thing I need to do is identify the center and also identify where is my major axis. Is it going to be horizontal or vertical? Now remember, in the standard form of the equation, you can see that my center is always going to be at hk. So in this case, where its center is hk, where in this case it's going to be x minus h squared over a squared, which in this case is 9, plus y minus 1 squared over b squared, which in this case is 4, equals 1. That's k. So therefore, since you can see we have a negative 2 and a negative 1, remember, it's x opposite of h. So opposite of negative 2 is going to be 2. Opposite of negative 1 is going to be positive 1. So therefore, I can say my center is 2, 1. And the next thing is, now I look at, all right, so my a squared I said was under the x. Whenever my a is under the x, I know that my major axis is going to be horizontal. So I'm going to have a horizontal major axis. OK, so now to be able to graph as well as determine the information, I think it's most important to plot what I currently have. So I have a center at 2, 1. So I'm going to go over 2, up 1. All right. So that is going to be my center, and I'll label it appropriately. Now, again, I'm going to have a major axis. So it's not really a part of your graph, but a lot of times I like to write in that dotted line, because what's so important about this is, remember, the major axis holds the center, which we already see is on there, the foci, and the vertices. And why that's so important is the distance from the center to the vertices is a. All right? Now, we notice if I want to find that distance, I'm going to be going left and right. The distance from the center to your foci is c. And again, I have to go along this major axis. So my vertices and my foci are all going to lie in this dotted red line, where my co-vertices is going to be perpendicular to that line. So again, let's figure out what a is. So if a squared is 9, we can say a equals 3 as I take the square root of both sides. So if my center is at 2, 3, I just need to go 3 units to the right to find one vertice and 3 units to the left to find the other vertice. So I'll go 1, 2, 3. That's vertice 1. And then to the left, 1, 2, 3. That's vertice 2. So let's go ahead and write these down. So I have my vertices are now at 5, 1, and negative 1, 1. All right. And one thing that's very important is notice that the center, the vertices, as well as the foci are all going to have the same y coordinates because they all lie on that major axis. The next thing we need to do is identify my co-vertices. So the co-vertices is going to be a distance of b from there. But remember, if this is the major axis, then my minor axis is going to be perpendicular. So now I'm going to be going up and down for my co-vertices. So if b squared equals 4, I can say b equals 2. So take the square root of both sides. So I'm just going to go up 2, So I can say covertice is at 2, 3, as well as 2, and just subtract -1. So that's covertice. That's my covertice. All right. Now, lastly, what I need to do is be able to identify what is my foci. So my foci is going to be distance of the square root of 5. So if I know c squared equals 5, take the square root of both sides. C equals the square root of 5. So again, I need to go square root of 5 to the right and square root of 5 to the left. Now, the square root of 5, I'm just going to approximate, is going to be anywhere between 4. Square root of 5 is anywhere going to be between 2 and 3. So I'm just going to go over 1, 2, 3. So just say here's one foci, 1, 2. There's the other foci. I'm just trying to approximate the best I can. And now, so when writing into my foci, again, I'm going from the center. So I know that the y coordinate is always going to be the same. I don't need to worry about that. I know it's going to be 1. All right? But now I just went 2 plus the square root of 5 and 2 minus the square root of 5. Right? That's all I put in. I took 2 and I added square root of 5, and then I subtracted square root of 5. So those are going to be my 2 foci. I have my vertices, my covertices, and my center. Now I just connect the vertices with the covertices, and I graph a very ugly ellipse, but that's going to be something where it's going to look at. So there you go, ladies and gentlemen. That is how you graph an ellipse as well as plot the information. Thanks. Welcome. So what I want to do is show you how to graph this ellipse, as well as determine the vertices, the foci, and the covertices, as well as the center. So to be able to do this, the first thing we've got to do is we've got to be able to determine, is my major axis horizontal or is it vertical? Because that's going to determine where I'm going to put my vertices and my covertices and my foci. The center is always going to remain the same if it's horizontal or vertical. So to do that, the first thing I need to do is I need to set my ellipse equation equal to 1. So I'm going to divide by 100 on both sides. Now this 100 is going to divide into both of these. Well, here I can reduce this down to 1/4, which would just be x squared over 4. You can put the 1 there, but we don't have to. Here, divide the 100 into 4. That's going to reduce down to 1/25. Again, you can write the 1 up here, but we don't have to. OK, so now we have it more in a standard form. And one thing I notice is I don't have an h and a k, right? Because when we're looking at that standard form, x minus h squared, y minus k squared, we don't have an x and an h. So therefore, the center is always in the form of h comma k. Well, since there's no h and k's for this, my center is going to equal 0, 0. And that's going to be very nice and helpful. The next thing is now I need to determine what my a squared is and my b squared. And when I'm looking at ellipses, it's very kind of obvious to be able to choose which one you want. A squared is always going to be your larger denominator. So I look at 25 and 4, and I can say, OK, obviously, a squared is going to equal 25, where b squared is going to equal 4. However, we need to be able to figure out what c squared is, because that's going to help us identify the distance from the center to the foci. So I say c squared is equal to a squared minus b squared. That is the equation that we're going to use to help us solve for c squared. So c squared equals 25 minus 4, which equals 21. All right. So now, after I've figured out my a, b, and c, the next thing I need to determine is where is my major axis, because it's so important for us to make sure we write down and understand that the major axis contains the vertices, the foci, and the center. I know my center, if I'm going to graph this, I know my center is at 0, 0. But are my vertices and foci going to be vertically or horizontally? So I go back and look at my equation. And whenever my a is under my y coordinate of my center, therefore, my major axis is going to be vertical. If these 25 and 4 were swapped, then my major axis would be horizontal because it would be under the x. So therefore, now I know my major axis is vertical. Now, since I know it's on vertical, it's going to be going up and down. My vertices and my foci are all going to lie in that line. Now, the distance from the center to my vertices is going to be the value of a. Well, right now, I just know what a squared is. So to find a, I take the square root of both sides. and a equals 5. So again, that's kind of like an absolute distance from the center to the vertices. So I'm going to go up 5, 1, 2, 3, 4, 5. That's one vertice, and then down 5, 1, 2, 3, 4, 5. That's my second vertice. To find my covertices, now, so you can see my major axis right here. It's kind of like a little dotted line. My major axis is vertical. That means my minor axis is going to be perpendicular to that, which will be a horizontal. And the distance from the center to the covertices is b. So to figure out that, I take the square root of both sides, and you can see b equals 2. So therefore, I'm going to go over 2. That's going to be covertice 1. That's going to be covertice 2. Now, to identify what my foci are going to be, my foci are again going to be the distance from the center to, the value c from the center to both foci. However, you've got to make sure you remember they're going to lie on the same axis, which is the major axis, as my vertices. So therefore, whatever my value of c is, to solve that, so c squared equals 21. Take the square root, take the square root. So c equals the square root of 21, which is roughly going to be between 4 and 5, 4 and some decimal. I don't know. I don't have a calculator. I'm not trying to be exact. I'm trying to make you have a good idea. So it's going to be between 4 and 5. So again, I'm going to follow on this major axis. I'm going to go up 1, 2, 3, 4. And I'm just going to estimate my point. And then down 4, 1, 2, 3, 4. And add a little change for 4, between 4 and 5. And those are going to be my foci. Now, again, obviously, if you're graphing or you need to find that exact value, we can go ahead and use a calculator. But I'm just trying to get an idea exactly where everything's going to be at. Now, to graph my ellipse, I'm just going to connect my vertices and my covertices. So there you go, ladies and gentlemen. Oh, I guess we can go ahead and write down what the vertices are. So my vertices are now going to be at my point 0, 5. And 0, negative 5. My covertices are going to be at 2, 0, and negative 2, 0. And my foci are going to be at 0, square root of 21, and 0, negative square root of 21. And where my center is at 0, 0. So there you go, ladies and gentlemen. That is how you take an equation of ellipse, graph it, and be able to identify the major important information. Thanks. Welcome. So what I'd like to do is show you how to graph this ellipse. But in order to graph this ellipse, we've got to make sure we write it in our standard form. And when we write it in our standard form, then we can identify is the major axis horizontal and vertical. And then once we know that, we can start identifying those values, and that's going to help us graph it. So the first thing we need to do is notice our standard form is x minus h squared, y minus k squared, right? Those are binomial squared. So I need to take this equation and rewrite it as a binomial squared. And obviously, we like it divided by the a squared and the b squared and so forth. So the first thing I want to do is group the x's and the y's together and then get the 144 over to the other side. Even though we know the equation has to equal 1, I'm going to worry about that at the end. So I have 9x squared plus 72x plus 25y squared minus 150y equals negative 144, right? I just subtracted the 144 over to the other side. I guess maybe I'll write that in there. OK, so now to write binomial squared, we got to create perfect square trinomials. And to create perfect square trinomials, we got to complete the square. So the first step in completing the square is getting your quadratic terms having a coefficient of 1. So what I'm going to do is I am going to factor out the coefficients of my quadratic terms. So in this case, I'm going to factor out a 9. And when doing that, I'm left with x squared plus 8x. And then here I can factor out a 25. And that's going to leave me with a y squared minus 4, 5, 6 minus 6y equals negative 144. All right, so now comes into the lovely part of completing the square, creating that perfect square trinomial. And to do that, when we have a quadratic in the form of ax squared plus bx plus c, to complete the square, we're going to take b divided by 2 and square it. All right, so here's a quadratic. I just don't have a c. In each one of these parentheses, I have quadratics. They just don't have c's. However, I can still take the value of b, divide it by 2, and square it. So therefore, I'll take 8 divided by 2 and square it. 8 divided by 2 is 4. 4 squared equals 16. Here I have negative 6 divided by 2 squared. Negative 3, that equals 9. OK, now I'm going to take those values and add them back into my equation. And I want to use all my colors again. So I have 9 times x squared plus 8x plus 16 plus 25 times y squared minus 6y plus 9 equals negative 144. Okay? Now, it's important for us to understand that I added a 16 and a 9 on the left side of the equation. So I got to add a 16 and 9 on the right side of the equation, right? If you add something on the left, you got to add it on the right. However, we got to make sure that when I add this on the left side, I added it inside the parenthesis. And inside the parenthesis, it's being multiplied by 9. So therefore, on the right side, I got to multiply this value by 9. And since I added 9 inside parenthesis here, that is being multiplied by 25. So I'm going to multiply this by 25. And it kind of seems like it's just going to be some math that I'm just going to use my handy-dandy calculator to be able to figure all this out here. So 16 times 9 is 144. Minus 144 is going to be 0. 9 times 25 is going to be 225. OK, so by doing all of this math, I end up getting 225. Now, the next thing I need to do is I see that each one of these parentheses, I created a quadratic. But what's important about completing the square is I didn't just didn't create any quadratic. I created a perfect square trinomial, a perfect square quadratic, one that I can factor now down into a binomial square. So I'm going to factor each of these into binomial squares. And when I do that, I now obtain 9 times x plus 4 squared plus 25 times y minus 3 squared equals 225, right? Because all of that adds up to 225. But however, remember to set this equal to, in our standard form, we have to divide by 225 because we want it to equal 1. And I divide each one of these other terms by 225. And then I'm going to reduce, I don't know how many times 9. So that goes 1 over 25, and that's over 25 times 9, right? OK, so when I divide these, this goes to 1. That goes to 25. Divide 25, or factor out 25. That goes to 1, and that goes to 9. Therefore, I have the standard equation, x plus 4 squared over 25 plus y minus 3 squared over 9 now equals 25 over 25 equals 1. Now I can graph my equation. Whoosh. OK, so one thing I noticed is, remember, our standard form of our equation is x minus h squared plus y minus k squared equals 1. Now, depending on what is your larger number, the larger number is always going to be your a squared for an ellipse. So since 25 is larger than 9, I can say the a squared is going to be under the x and the b squared is under the y. And when the a squared is under the x, that means I have a major axis of symmetry, which is very, very important. So now let's get into what information do we need to know to graph. First thing I need to know is the center. And the center is in the form of h comma k. So it's opposite of h, opposite of k. So in this case, my center is -4, +3. It's the opposite of your h and your k. The next thing is I need to figure out what is a squared, what is b squared, and what is c squared. Well, a squared is 25. B squared is 9. And c squared, we don't have anything for c squared there, but there is a relationship for a squared, or for c squared, which is a squared minus b squared, which is equal to 25 minus 9, which is equal to 16. So a squared and b squared and c squared are helpful, but really what we want to know is what is a, b, and c. So if a squared equals 25, that means a equals 5. If b squared is 9, that means b equals 3. And if c squared is 16, that means c is equal to 4. Now again, what does a, b, and c represent? A represents the distance from the center to your vertices. B represents the distance from your center to your co-vertices. And C represents the distance from your center to your foci. So with all that information in store now, I can plot the center, which is at negative 4, 3. 1, 2, 3, 4. 1, 2, 3. And remember, since a squared was under x, that means I have a horizontal major axis symmetry. The major axis of symmetry is where your foci, your center, and your vertices are all going to lie. So when it says a is 5, I'm going to go to the left, or to the left for you, and to the right 5 units to find the 2 vertices. So I go over 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5. And then to find the co-vertices, that's going to be on the minor axis symmetry, which is perpendicular to my major axis. So that's going to be up 3 units and down 3 units. Then the foci, again, has to lie on the major axis. That's going to be 4 units. So I go over 4. 1, 2, 3, 4. 1, 2, 3, 4. And let's label these here. Foci, foci, vertice, vertice, co-vertice, co-vertice. The last thing I like to do is let's go and label the points. Because by graphing this, you just connect the vertices and the co-vertices. All right? So we know the center is at negative 4, 3. The foci is just 5 units to the left and to the right of the center. So basically, all I'm doing is subtracting 5 from the x-coordinate. So that's going to be negative 9, 3, and 1, 3. Right? Notice the y-coordinate stays the same, right? They're on the same horizontal line. That's not the foci. That's the vertices. But the foci is the same thing as the vertices. It's just left and right. However, it's only 4 units. So I'm going to subtract 4, and I'm going to add 4 to my center. So that will give me negative 8, 3, and 0, 3. So notice how the foci and the vertices and the center all have the same y-coordinates because they all lie on this major axis, which in this case is horizontal. So therefore, the y-coordinates are always going to remain the same. And the last thing is our co-vertices. Now, our co-vertices are going up and down. So therefore, they're not going to change horizontally. They're only going to change vertically. So I go to my distance from my center to my co-vertice is 3. And I'm just going to add and subtract that to 3 as negative 4 remain the same. So I have negative 4, 6, and negative 4, 0. So there you go, ladies and gentlemen. That is how you graph an ellipse by writing it into standard form and then identifying your vertices, foci, and co-vertices. Thanks. All right, so I decided I didn't want to do any more videos. I'm like, all right, I'll do one more. And then the next video I have to create is this lovely one. Not the most exciting or quickest problem to go and do. But what I'm going to try to do is show you how to graph the ellipse given this equation. Now, when graphing an ellipse, we want to make sure that it's in our kind of vertex form or our center form where we know where the center is, as well as how to identify the major and the minor axis. This is not in that format. And so to do that, we need to complete the square. We need to get 2 binomials squared, right? We want to get it as x minus h squared, y minus k squared, right? We want to get those binomials squared. So to do that, the first thing I'm going to do is I'm going to group the x's and the y's together. And remember, we want it to set equal to 1 at the end. So we'll get the constant over to the right side. So I have 3x squared minus 18x plus 4y plus 24y. I'm sorry, that's 4y squared. Equals negative 3. So I subtracted 3 on both sides. And then I just regrouped them together. Now, again, what we're trying to do is we want to create perfect square trinomials. Right now, if you just kind of look at these, we just have 2 binomials, right? I want to create 2 perfect square trinomials. So to do that, I have to complete the square. But to complete the square, we got to make sure that our quadratic terms have a coefficient of 1. So I'm going to factor out their common factor, which in this case, for the x's, would be 3. So therefore, I'm left with x squared minus 6x. Plus here, the common factor would be 4. So y squared plus 6y equals negative 3. Okay. So now, to create the perfect square trinomial, I need to take b divided by 2 and square it. And remember, b comes from ax squared plus bx plus c. That is the standard form of a quadratic, where b is the coefficient of your linear term. So I'm just going to take negative 6 divided by 2, square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is equal to a positive 9. Here I have 6 divided by 2 is 3. And I get 3 squared is equal to 9. Cool. Actually, I have the exact same ones. That's going to be kind of interesting. I don't think I've actually ever had a problem like this. I like this problem. So now I'm going to add these two values inside of both of my parentheses. So now I have 3 times x squared minus 6x plus 9 plus 4 times y squared plus 6y plus 9 equals negative 3. Okay? So by adding 9, what I have done is I've created a perfect square trinomial, a binomial that I can factor down, or a trinomial, I'm sorry, I can factor down into a binomial squared, meaning a factor multiplied by itself. And you can see they're exactly the same. The only difference is here my middle term is negative, here my middle term is positive. So by factoring these, I obtain 3 times, oops, sorry, I got a little too quick to myself. All right, so I added 9 inside the parentheses, right? But since I added 9 on the left side, I also have to make sure I add 9 to the right side. And notice that this 9 is being multiplied by 3. That means this 9 has to be multiplied by 3. But then I just didn't add 9 once, though. I add 9 again. And that 9 is being multiplied by 4. So I need to add 9 again, and then this time multiply that one by 4. Sorry, sometimes I get a little excited, and I move ahead. All right, so by factoring this down, I get 3 times x minus 3 squared plus 4 times y plus 3 squared equals, now I just need to combine these, so really it's negative 3 plus 27 plus 36. So that's going to be 24, 50, 60. Okay? So when I add these all up, I get 60. Okay, now remember the equation of an ellipse is equal to 1. So therefore, I need to get that to 1, so I divide by 60. Now remember, the 60 divides into both of these expressions, okay? So therefore, 60 divided by this, I get x minus 3 squared over 20. Plus here, I get 15. Y plus 3 squared over 15 equals 1. Okay, so now we found the equation. We haven't even started graphing though yet. So I'm going to erase this and graph above. Isn't this fun? All right. So now we know, we look at this and we say, all right, the larger of my two numbers is under my x. So therefore, I know the major axis is horizontal. Therefore, from the center, I'm going to go horizontally to find the foci and the vertices. So the general equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. Perfect. Okay. So now to graph this, let's just kind of start writing down what we need to know and then how to graph. So the first thing I always like to know is where's the center? Well, the center is h comma k. So in this case, we can say the center is at, remember, it's always opposite of h, opposite of k. So it's going to be 3 comma negative 3. Yes. So on my graph, I go positive 3, 1, 2, 3, negative 3. And I just label that with a C as a center. Actually, I'll go above because it's a major axis. All right, so the next thing is determining your vertices. Ooh, we got to find foci too. OK, so the vertices have a distance of the center, a distance from the center on, now remember, our major axis is horizontal, right? So we're going to go in left to right. But the vertices, the distance from the center to one of your to a vertex is the distance of a. So I need to figure out what a is. Right now I know a squared is equal to 20. So a is equal to the square root of 20. Now,
you can find the exact value. You know, we can rationalize this. And when we find the exact points, I like to simplify that. 4 times 5, which is equal to 2 square root of 5. However, when graphing, we kind of want to know what the decimal is, right? So we know it's approximation. It's going to be between 4 and 5. It's some decimal in between 4 and 5. So I'm going to go to the right 4. 1, 2, 3, 4, 5. So in between 4 and 5, and also to the left between 4 and 5. 1, 2, 3, 4, 5. And I'll say vertex, vertex. So when labeling, though, the vertices, I'm going to use actually the exact distance and say, all right, so from the center, I added 2 square root of 5, and I subtracted 2 square root of 5. Well, the x value of the center is 3. So I'd say 3 plus or minus 2 square root of 5, comma, negative 3. As you notice, they all have the same y coordinate. Next thing, let's do the covertices. I'll put those over here. So the covertices have a distance of b. Well, b, another fun one, b squared equals 15. So therefore, b equals the square root of 15. Now this one we can't simplify, which that's fine. But we still need to be able to identify what is like the decimal version of that. Well, it's going to be anywhere between 9 and 4, probably, not 9, I'm sorry, 3 and 4, right? Because 3 squared is 9, 4 squared is 16. So it's going to be some decimal between 3 and 4. So that's going to be on the minor axis, because b represents the distance to the covertices, which is perpendicular to my major axis. So I'm going to go between 3 and 4. So up 1, 2, 3, 4. So some a decimal there, and down 3 and a decimal. 1, 2, 3, 4. So down somewhere in between. So that's a covertex, covertex. Now notice how for the covertices, I went from the center, I add and subtracted the square root of 15 from the y coordinate, as the x coordinates stay the same. So my covertices are going to be 3 comma negative 3 plus or minus square root of 15. Take note the difference between how I wrote the covertices and the vertices, right? Covertices, since this is a horizontal major axis, I add plus or minus to the x-axis, and I add and subtract to the y coordinate for the covertices. The last one is going to be the foci. Now, to find the foci, we got to know c squared. And the relationship we have for c squared is equal to a squared minus b squared for ellipses. So c squared equals 20 minus 15. C squared is equal to 5. So therefore, c is equal to the square root of 5, right? Take the square root of both sides. OK, so to find the foci, I'll do this on the same side. Remember, the foci is on the major axis. It's on the same axis as the vertices center and the other, or the vertex center and the other vertex. So therefore, I'm going to be adding left and right from the center, just like I did with the vertices. Again, to estimate this is going to be between 2 and 3. So it's going to be left 2, 2 and a decimal, and right 2 and a decimal. I mean, you can find the exact value again if you want to. There we go. There's my lovely equation of my ellipse. And then to write my exact values of my foci, I'm just going to take my x-coordinate of my center, which is 3, add and subtract square root of 5, which cannot be simplified. And then you notice that it also has the same y-coordinate as the center and the vertices. So there you go, ladies and gentlemen. That is how you write an ellipse in the standard form, as well as graph the ellipse. Thanks.
So what they're asking us to do for this problem, actually I wrote my book. I believe in this problem they're asking us to graph it. So far, Dylan, what we've practiced is we've been practicing writing the equation, writing the equation, writing the equation, writing the equation. Now I'm giving you an equation and I'm asking you to graph it. The problem is this doesn't look like the equations we've been dealing with, right? So if you guys remember when we had parabolas and we had circles, if we remember both our forms, we need to write it into that format when we had those squares, right? When we have our perfect squares, our binomial squareds, right? So what I need to do is I need to rewrite that. So the first thing I'm going to do is rewrite this so my x's and my y's are next to each other. So I have 3x squared minus 6x plus y squared minus 8y. And I'm going to add the 5 to the other side. Because, right, it always equals 1, right? It doesn't equal 0. It equals 1. So
We know there at least has to be a number over there to get this to 1. All right? Now, the next step is I need to get a binomial squared. So the process for getting binomial squared is completing the square, right? So we're going to do it twice. We're going to do it for these two. We're going to do it for these two. All right? So we look at this one and we say, all right, I can't complete the square until I factor out the 3, right? Now, can I complete the square? Yes. Take my b, which is -6, divided by 2, and square it. -6 divided by 2 is -3. -3 squared is 9. So I have 3 times x squared minus 6x plus 9. Here, I take my b, which is -8, divided by 2, square it. -8 divided by 2 is 4. -4 squared is 16. OK. So we got to that point, right? Does everybody follow me? Yes. Because remember, I had to oh, you're right. Jeez. Thanks, Stepanica. Good work. Just want to make sure. So you factor out at 3, x squared minus 2x, right? Yes. So therefore, it's going to be 3 times x squared minus 2x plus 1. Now does that make sense? Better sense, right? Thank you very much. OK. So now we need to make sure, though, we added. So now when we completed the square, you guys got to remember, when you complete the square, you're actually adding a term, right? We're taking our number, dividing it by 2, squaring it, and then we're adding it. So we got to make sure if we have an equation, if we add something to the left, we got to make sure we add it to the right. So we multiply by 1, but that 1 is being multiplied by 3. So we got to make sure we do that on the other side. Then we have a 16 we added. So we got to add the 16 as well. All right? We got it? OK. So now remember, the whole reason why we complete the square is to create a perfect square trinomial. Why do we like perfect square trinomials? We like perfect square trinomials because we can factor them down to binomial squares. So if I factor this, I get 3 times x minus 1 squared plus this factored is going to be y minus 4 squared equals 5 plus 3 is 8 plus 16 is 24. All right. Now, we still have a little bit of an issue. Look at this, because remember, our equation for our standard form of a graph looks like this. X minus h squared plus y minus k squared. And then it's either a squared or it's either b squared equals 1, right? It's one or the other. So we don't have any numbers being multiplied as of right now times our coefficients. So to figure this out, to figure out our a and our b, I need to get rid of this 3. Or actually, I'm sorry, anything. I need at least this to equal 1, right? This needs to equal 1. So to do that, what I need to do now is divide by 24. So I'm going to have to make sure I divide everything by 24. OK? Therefore, I get now x minus 1 squared over, this reduces down to 1/8, plus y minus 4 squared over 24 now equals 1. So now you guys can see, what is the larger of my two denominators? 24 or 8? What's the larger number? 24. So you guys can see that my a squared is going to be under my y, and my b squared is under being my x, which now tells you if your a squared, which is your largest term, is under the y, you're now going to have a vertical, right? Yes? -3, 8. I just wanted to.
Okay, so wait, where'd you get? Oh, okay. Never mind.
OK? Got it? Told you it was hard. So now we need to go and figure out what everything we know. So now we can determine our center. Our center's at where? 1, 4. Right? So now we know a squared is going to equal 8. B squared equals 24. And remember, to find our c squared, we know that a squared equals b squared plus c squared. So a squared equals b squared, which is 24, plus, yeah, yes.
Why is it that B is 24? B squared is 24, you said A squared is 300.
Remember, the formula is b squared over a squared. Oh, I'm sorry. You're right. OK, thank you. A squared is 24, right? B squared is 8. Thank you. I messed that up.
Oh my gosh.
So you have 24, and that is your 8, plus your c squared. Yes? Then we subtract 8.
What are you looking at?
16 equals c squared. Take the square root, take the square root. C equals 4. OK? So a squared, this is going to be a decimal, right? If we try to simplify that, right? So a equals the square root of 24. B equals the square root of 8. But c equals 4. So at least we know one even number that we'll be able to figure it out. So we're going to have to approximate for a and b as we graph it. But we'll go to work this. Everybody has this work done? This right here? OK. Well, let me go and erase the problem. Is that OK?
Yeah.
All right. So let's go and do the graph there. So we know that since our a squared is under our y, we know it's going to be a vertical one. So let's just double check to make sure we have this. So the first thing I'm going to do is write in the center. The center is at 1, 4. Over 1, 1, 2, 3, 4. Right? Then, now, if we know what the center is, now we need to determine what the vertices are. Now, we know the vertices have to be vertical, right? So from my center, which is at 1, 4, I need to now go up and down, right? Because that's all going to be on your major axis. So to find my vertices, vertices is going to be square root of 24. So I need to figure out what the square root of 24 is, which is roughly going to be 4 and some change, almost a 5, right? Square root of 24? Yes? So what you can say is for the vertices, your vertice is going to be 1, 4 plus the square root of 24. And it's going to be 1, 4 minus the square root of 24. You understand your center, right? Your vertices is your distance a from up. Here's your ellipse, right? Here's your center. Here's your vertice. Here's your vertice. The distance from here to here is a. The distance from here to here is a. Correct? So what is a? A in our case is the square root of 24. Right? So if I give you the center, to find v, or find your vertice, you just need to add the square root of 24, right? To which coordinate of your center, though? The x or the y? Since you're going up, you're going to want to add it to the y coordinate, which is k. So that's why I have your vertice is going to be 1, 4 plus square root of 24 and minus the square root of 24. And the square root of 24 is 4 point. So it's going to be 4.8. OK. So 4 plus 4.8 will be like 8.8. So we could go 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be almost up to 9. And then this one down, 4 minus 4.8 is going to be like a negative 0.8. So it would be 1, 2, 3, 4, down to there. Then I need to go and determine my focus. So now my focus is a distance of c. And so since we're adding in plus or minus c, I'm going to go up 4, 1, 2, 3, 4. That's going to be my focus. And down 4, 1, 2, 3, 4. Because remember, your center, your vertices, and your foci all lie on the major axis of symmetry. Notice the distance from the center to my vertice, ladies and gentlemen, this distance is the square root of 24. This distance, the distance from my center to my foci, was 4. All right? Now to finish up the graphing, I do need to figure out what my b is, which is the square root of 8. And the square root of 8 is 2.828427, roughly, first 5 digits. So to go from the middle, if I have here is at 1, I need to add 1 plus 2.8, which would be 3.8. So 1, 2, 3. So it's almost up to 4, which would be out there. And then minus. So 1 minus 2.8, which would be 1.8. Negative 1.8, which would be right around there. And there's what your parabola looks like. OK? So the main important thing that you guys need to do, this one's a little bit difficult because you're approximating values. The main important thing you guys need to know, though, is how to take it in your standard form to write it into your vertex form. Make sure it equals 1. Then you at least know what the center is, and you can find your a and b. Once you guys know the center, your a and b, you can find the value for your foci, and then you know your major axis and your minor axis. OK?